Today we're going to be in the Unit 6 notes packet in Roman numeral 4, writing compounds. You're going to get a name of an ionic compound and going to write the formula based on the name. Here are some simple steps. When writing ionic compounds, A, write the symbol for the cation with its charge. Write the symbol for the anion with its charge. C, cross the charges. D, reduce subscripts if possible. Let's look at some examples. We'll start with sodium bromide. The cation in this case is sodium. Na has a positive 1 charge. We know this because it's an alkali metal in the first group of the periodic table. Bromide comes from the halogen bromine, Br with a negative 1 charge. So we have the cation with its charge, Na plus 1, the anion with its charge, Br minus 1. To cross the charges, we bring the number value down from the positive cation to the subscripts of the anion, the negative anion to the subscripts of the cation. Again, we're only bringing down the number, not the positive or the negative. I can rewrite this here in red, NaBr, because there was one Na and one Br when I crossed the charges. This is sodium bromide. The next one, calcium. Ca has a positive 2 charge. Bromine again has a negative 1 charge. Crossing my charges. That's the same thing that we did when we said calcium had 2 valence electrons and bromine had 7. Calcium had to give away its 2. Each bromine could receive 1, so we needed 2 bromines for the calcium. This is just a shortcut version showing the 2 and the 1. 1 calcium, 2 bromines. It was good to do this way first because now you know truly why the formula is CaBr2. Now pause and try the next 3 on your own. AlBr3, aluminum bromide. Aluminum oxide is Al2O3. Aluminum phosphide gives us an opportunity to see where we can reduce. Recall in the steps, we wrote the cation with its charge, anion with its charge, cross the charges, reduce if possible. In this case, 3 and 3 can be further reduced to 1 and 1. None of the other problems allowed for this type of reduction, but instead of Al3P3, we're doing AlP. So far, when we've talked about ionic compounds and writing their formulas, the cations and the anions have always had the same charges. This is different for the transition and other metals. The charges of the transition metals and the metals in the P block may vary. Remember when we were going over the periodic table, we said alkaline metals always are positive 1, alkaline earth metals are positive 2. We skipped over the transition metals to say aluminum was positive 3, and then we skipped the other metals in the group 4. Now we're going to go back and look at those. The charges may vary. The ones that are always the same are silver, plus 1, and cadmium and zinc are always plus 2. Lead and tin in group 4, as well as all the other transition metals, can vary in their charge. For example, iron might have a positive 2 charge, and it would be written as iron Roman numeral 2. Or iron Roman numeral 3 is iron with a positive 3 charge. We treat these just the same as any other ion, but you have to be told what the charge is. Here are some examples for silver, cadmium, and zinc. Go ahead and pause as you check these in your notes and write them down. Now we can do lead Roman numeral 2 and lead Roman numeral 4. The difference between these is in their charges. They both have chloride as the anion, Cl-1. When you cross the charges, you can see that the different charges for lead give different formulas, PbCl2 or PbCl4. Now that you have practiced writing the formulas for some simple binary ionic compounds, it's time to try some with polyatomic ions. The method is the same, you just have to use the polyatomics and keep them in parentheses when you use the charges and cross them. For example, ammonium is NH4 with a positive 1 charge. Notice that I've written it here in parentheses with the +1 on the outside. When paired with bromine, Br-1, if I should cross my charges, there is only 1 ammonium and 1 bromine. For this reason, when I rewrite it, NH4Br is fine. I don't have to put it in parentheses. Had there been another charge, I would have had to. Here's an example. When ammonium is now paired with sulfide, S, -2, notice that the 2 goes to the outside of the parentheses. This time when I write my final answer, I need to use the parentheses. Parenthesis, NH4, end parenthesis, 2, with an S on the outside. I can also use polyatomic anions, like sulfate. Notice I started with sulfide. IDE indicates that a nonmetal has been used. Sulfur changed to sulfide, bromine changed to bromide, oxygen would change to oxide, etc. Remember, if you have an 8 or an ite, it's from that polyatomic list on the back of your periodic table. So here's aluminum +3, sulfate SO4 -2. In parentheses, I'm moving the 2 down to the aluminum. I'm going to take aluminum's 3, move it to the outside of the parentheses from sulfate. That's Al2 parenthesis SO4 3. Now pause and try the next 2 on your own. Aluminum sulfite, Al2 parenthesis SO3 3. Barium phosphate, Ba3 parentheses PO4 2.